Hidden Layers. Meet the people behind the data. With Uri Elabayev.
תודה רבה לכל מי שמצטרף אלינו. קוראים לי אורי אליבייב, ואנחנו בפרק נוסף של Hidden Layers. יש לנו אורח מיוחד מאוד שהגיע לנו מחול, ממש לתת לנו קצת את הטייק שלו ואת הזווית שלו לעוד הרבה נושאים מאוד מרתקים. את הרעיון הזה אנחנו נעשה באנגלית, כחוויית האורח שלנו, אבל אני מזמין אתכם לבוא ולשמוע גם את הפרק הזה וגם את הפרקים הקודמים שלנו. היום פרק ממש מיוחד על AI בקצה, על Inference, על כל הנושאים שאנחנו מדברים עליהם הרבה. ויש לנו פה באמת אחד המומחים הגדולים בתחום, מחברה שממש מעניין, גייסה הרבה כסף, עושה דברים מאוד מרתקים, ועל זה הולך להיות הפרק. אז without further ado, let's start. So hi. Thank you for joining us.
Thank you for inviting me.
Yeah.
I have to just say my Hebrew is rusty, so I cannot keep up with that.
No, we will do that in English.
All
It's
right.
all good. So, Harry, it's good to have you here, and it's really fascinating to learn about what you are doing. And I'll be happy to start with just introduction. Tell the audience a little bit about yourself, then
Sure.
we'll move on.
Yeah, sure. I'm a little bit non-typical for the topic here. I'm a natural-born nerd, I have to admit that, but I was in car business all of my life. So I was 20 years with a company called Mercedes-Benz,
Yeah.
and then 5 years with Bosch, and my last position there was running all of their automotive business. A lot of people know only Bosch for dishwashers, but actually they have a very strong automotive business.
Oh, really?
They're the number one automotive company, actually.
Really?
Yes, they have the biggest market share for engine controls,
wow.
computing in the car, stuff like that. So I did that and decided for a radical step in 22 to do something completely different. And so I went from a huge company to a really small company.
Mm-hmm.
And I'm a father of 3 kids,
Nice.
living in Germany,
Mm-hmm.
but being on the road a lot because in my role I'm running all of sales for my little company we talk about later.
Yep.
And sales always means worldwide. So a lot of traveling.
Perfect. So we are very glad to have you here. Now let's speak a little bit about the company SiMa AI that we are here wishing to learn more about that. So can you give us a little introduction about the company?
Yeah. I think SiMa has a very exciting proposition, which was quite unique when they founded the company 6 years ago. And the idea was everything machine learning AI will move to the edge. That was the basic hypothesis at that time. And that at that time was an outlier. At that time,
6 years ago.
6 years ago.
Yep.
So the whole story was there's the data centers, there is maybe the phone world, what you do there, but everything in between nobody takes care of.
Yeah.
And the idea was the answer will not be to abuse graphic cards for that business because they're too power hungry.
Yeah.
The
The
answer-
GPUs. The actual
GPUs,
yeah.
exactly. The answer will not be use DSPs that were made for smartphones and abuse them for machine learning or inferencing. But the world needs something which is just designed for that purpose, to do this very fast and very power efficient. And that was the starting idea 6 years ago.
Right. So that's lead the founders to just try to build. What was your first problem? What was the vision, and then later on what you
So I'm with the company now 2.5 years, so I wasn't part of the founding crew. But what I learned from the founders, a lot of the guys came from the FPGA side of things. So they knew how does a completely per software controllable compute look like.
Yeah, FPGA. Do you want to elaborate about that?
Well, FPGAs, I think, are the most complex and most performant compute units you can buy. They're expensive, but they're completely flexible, and you can do any specific task with the speed of light faster than on any CPU you would ever be able. And the idea of the founders was, what if you take that basic idea and map it on machine learning?
Yeah.
Like create something where everything is controlled by software. So you don't try to put certain CNNs into silicon. And if you take a different
several companies have tried that.
Exactly. That's a dead end street because machine learning is evolving so fast. So you want to be flexible. So take the flexibility of an FPGA and map it onto the world of machine learning and design something that is perfectly suited to do this kind of inference.
So this was like the vision. So meaning that you want to build something that will be robust, that you take almost any AI application,
yes, exactly.
any architect or network, and you want to put it on a chip, right?
Yes.
So the basics try to do the first R&D, try to find a way to build it. So what they've managed to come?
So today, actually, we're right now launching our second chip already.
Mm-hmm.
I'm always trying to emphasize that machine learning is not about a chip alone. You always need to have the right software because people doing their applications in high-level languages like PyTorch or TensorFlow.
Yeah.
And what you really need to achieve is you need to build this bridge between this high-level world the guys are doing their applications in and the secret sauce you put into your chip.
Exactly.
Because you don't want to have the application engineers to try to figure out, okay, how do I play with that chip? You want to have a software, a compiler that maps your high-level network that you describe onto the secret sauce of your chip to be very efficient, very fast. And that is, so our product is, yes, it's 2 chips, but I think the crown jewel is as well the software that comes with it that does the translation from, let's say, PyTorch onto
the chip. So basically, if I get it right, you have 2 main chips that you are developing, but the most important part for you is to make the work of the machine learning engineer or data scientist seamless. They still write the same code, train the same model. They don't need to do much in order to make it suitable for your hardware, right?
Yes.
And then just run the model and then run it on your chip, basically.
Exactly. And our claim, like when we do a company presentation, sometimes my first slide is we're a software company building our own silicon. That's really the first slide. And as an engineer, coming more from the hardware side, I'm an electrical engineer. At first I thought, I know this chip is everything. But I understood over the years now, I understood the importance of software. That's really the key element you need to have. And I think the important part is you need to think about that from day one. If you build a perfect piece of silicon and then you start thinking about software, it's too late. It's like you build a house and then you think about, I would like to have a basement. Then it's too late. Then you have to
or maybe the pipes. Right.
Turn then the house and build a basement. You have to think about that from day one. So the co-design of software and chip, that is, I think, is the magic behind our company, that we did this from day one.
Yeah, it's fascinating to, with the majority of the time we speak with hardware organizational companies, we talk about the actual silicon. But as you mentioned, and I see more companies are starting to acknowledge that you need to also have the layers of the code, because we saw many companies that try to compete with some of the most popular, and the data scientists, even it will be like half of the cost with 10x performance, we still don't want to do anything with that, because we are not going to rewrite our entire code. We are not going to debug things that we cannot understand. And
reinvent everything. And if you spend like 100 times more engineering hours to make it run, the break even on that investment is really tough. So this is why this part of make this transmission as effortless as possible was a big story behind our company from day one.
Yeah, so you started through, as you said, writing the software for that from day one. Started to build the chips and orchestrate it all together. And then you had your first product, second product. Can you a little elaborate on that?
Sure. So the first product, I think, came out 22. And actually that was how I was sucked into this company. The founder came to my hometown in Germany at that time. And I knew about his ideas since day one. So he came to me just with a bunch of PowerPoint slides. And at that time, I thought, that's a really cool project. But I was skeptic.
Did he have did he say the same slide with software first, as you said?
Yes, exactly.
He had the same.
And I looked at this as software. Wow, chip. You do your own chip. So I was admiring the idea, but I was super skeptic. And 3 years later, he texted me and said, we need to talk to each other. And he showed up in my town and said, let's meet for breakfast. And the first thing he did is he threw the chip on the table and said,
The actual
we've
one.
done it. We've done it.
Oh, wow.
And I said, oh my gosh, this is really impressive. And then he showed me what they do and the first benchmarks and stuff like that. And then I was hooked. And I said, at that time I was eyeing a big company as my next step. And I said, no, I'm going to go all in on this company. I think this is super exciting.
Yeah, and this is the interesting part because it's not taken for granted because building chips that actually works, it's very complicated. I think people don't understand, everything the design, manufacturing, debugging that. This is much harder than just writing software. And people say, okay, just build a chip. But as you can tell, this is very, very complicated. The heat distribution, all the semiconductor, and just to get, companies to manufacture that for you.
I still believe of all the wonders that mankind invented, if you think about what's happening in those billion of transistors, this is mind-blowing. On a couple, let's say 200 square millimeters surface, what complexity of structures in there. If you think about this, is mind-blowing. So yes, I have deep admiration for people doing this. But you have to see, it's of course, they built a lot of great tools to get there. It would be impossible if everybody doing a chip would start with putting transistors together. So you have those very
building
powerful
blocks.
building blocks, and you have companies that offer building blocks. But in the end, what we did for the machine learning part, nobody did before. So this was completely, some really smart people in SiMa invented that and said, this is how we want to do it. And our company that's actually doing the chip is TSMC, the guys in Taiwan.
And this is the fun thing, 6 years ago, you probably managed to get your line for TSMC. Nowadays, there's no way they will enter a new chips, no?
That's right. At the same time, when the first chip came from the fab, and we tested it, and we called them back and said, hey, the chip is fine. It's first time right.
Wow.
And they said exactly that. They said, oh, this is really impressive. Like, we have big names in the industry that take 3 tries, and then they're proud that they only took 3 tries to make it right.
Yeah. So the question is, if you did your job right or they did their job right?
So they basically said, who are you guys doing such a complex product first time right? So, and they looked at us and today, they're really good partners of ours. And I can say already the second chip was first time right too. So they told us it's 5% of companies get something first time right. So it's now 5% squared that we have as a probability. And that, to me, and I say this because I wasn't part of that, I can be proud on that. We have some exceptional people doing this because they know what they do. And this is maybe special. We're a startup, but we have an interesting mixture of people. It's not this startup where you have 50 people coming fresh out of university. They would make a ton of beginners' mistakes.
Yeah, they won't make it in the first chance.
Exactly. But in this case, we had a lot of people very good in... They made all the mistakes in other companies before. So in this case, they knew exactly what to do. They tested, they virtualized. And I think when they did the tape out of that chip, they knew it's going to be good. And that's something I deeply admire.
You need to be bullish on your walk,
Yes,
to be
you need to be really a master of what you're doing. Right? I mean, to be ready to do that.
So you say the first chip came out, the second one, and basically the chip is like a chip that is aimed for edge devices, right? That you can put it on. You will mention in the cameras, in robots, in drones. You will explain a little bit about that.
Yes.
And as you said, you also write in the software. So you basically write a compiler that allow me to do this translation between the code I wrote to the code that can run on your hardware.
Exactly.
So I'll be happy to just a little bit to get more explanation about the actual chip and what is the usages, and also the software implication that you wrote for that.
Yeah. So maybe I start with the use cases because that makes it a little bit easier. Because sometimes people say, what's wrong with the cloud? Cloud works. You could say, well, a lot is wrong with that. If you look at the energy consumption of those data centers, like when they build something new in the US, they always ask for building a nuclear power plant right next to it.
Yeah.
So there's a lot wrong with data centers as they are today.
There was a meeting yesterday with Macron with Sam Altman, and the conspiracy was that Macron has a lot of nuclear plants. Sam Altman need a lot of power. So
The thing is, I think, why is Edge so interesting? Edge is the only way you can get ultra low latency, meaning your reaction on something, and I'm going to give you some examples, is almost immediate.
Yeah.
And I always compare this with us as humans. Think about, we would run through this world and it would always take 30 seconds till we understand. We would bump into every chair, every door, every person.
Yeah.
The world we live in is made for understand really fast what's in front of me, so you can interact, you can do something.
Wow.
And this fast reaction is super important. I sometimes make this example. Think about a robo-taxi, like an autonomous car, and you drive in this car, and like 1 minute after you crashed into the tree, you get the message, be careful, there's a tree coming your way. That's not
1 minute later.
Exactly, that's not a good use case. So I think Edge is really, this is one of the key elements, but there's other applications as well where you think about privacy. If you have cameras that watching people, you don't want to store this video, you don't want to send the video somewhere without the consent of the people. But if you process that right there, you're completely clean on any data protection, so you just extract the information that's relevant there.
To get the insight, the meta information.
Exactly, to understand what you want to see. For example, we have an application where I think it's very fascinating. I'm as I said, I'm an engineer, but everybody of us goes into retail stores and buys stuff. If you think about it, if you buy a car, you go into this place, you look at the cars. Car people don't know much about what's happening on their showroom floor. So what they're interested in to try to understand, well, if you come in there, how many minutes do you spend in front of that model or in that model? Or maybe they have two colors, which is more interesting to you.
Yeah, like A/B testing. Yeah.
Exactly. And if you put this in the store, you get this free of charge. You could get even regional differences, like, hey, in Tel Aviv, they like the white ones, and in Jerusalem store, they go into a different color. You can get to completely different performance measures of your stores, but you cannot send the data somewhere. So you need that information, you extract it right there, and then you have it. And that's a big, big topic. And the last topic I would mention on Edge, it's a great cost position, basically, right?
Yeah.
I mean, sending continuous video to the cloud is very expensive. Yeah. And any customer we have, so even customers that for some reason don't care for latency or have no privacy story, they say the cost, like 1 year, we're break even. We buy your equipment, and after 1 year, we have a much better cost position than if we'd run with a cloud service on that.
Yeah.
So these are the reasons why Edge is so interesting. And every day when I talk to a customer, I see new applications that I have to say I never thought about before, where the customers have these ideas and say, well, you know what, we would like to do this, I would like to do that. And I think this is an interesting time we're entering now, seeing all those possibilities.
Yeah, I see also, in my perspective, you mentioned the latency. I have several Google Homes products in my home, and as if you need to ask something, and then you need to wait, and then they need to figure out what you wanted for them, and then they respond, but they don't get it right. So you need to you wanted to do something, but instead of it, just spend your whole minutes trying to get them understand because it takes some time. And also the element of privacy. This is something we see becoming very important as the models becoming so general understanding, because this is not only the sensitive data of what you are buying or this is actually conversations or photos that you are taking. This is have a lot of meaning and understanding of what is the actual data. And you see companies like Apple, like Samsung, and many others, or even Microsoft, the laptops say, okay, we want to give you those features, but we understand that this could be a little bit spooky if it will be out of scope or without just staying in your device. So let's put a very effort on privacy. And also, as you said, the cost. This is something that I see with many of my clients that say, okay, the cloud is great. This is great for benchmark, for the POCs, to see if there's any measure of understanding this tool can actually be built for something. But then later on, you say, okay, we want to do it on scale. We want to give as much as possible to all customers, billions of customers. And then you say, but it doesn't make any sense cost-wise. So why should we do that? And I'll be happy to hear from you a little bit of use case for every pillars of those as we start. Maybe the privacy, latency, cost.
You're absolutely right. The cost position and the privacy part are often overlooked in the beginning. And I think everybody of us had this weird moment when we saw the first meeting summary written by a computer. Then we realized, oh my God, this is pretty accurate of what's happening. And you don't want a meeting summary of your dinner table, right? Like at Google, like, oh, look at this family. They talked about this and that. So I believe it makes a ton of sense. And what I like, you made this point about you waiting on your Google device or on your Alexa or Siri or whatever. I think there's this magic barrier. When does it feel completely natural in terms of conversational
I think people
speed?
measure there's a millisecond.
Exactly.
There's a number for that.
There's a frontier. If you're beyond that, it feels natural. Anything before that, you're talking to some kind of machine and it feels weird. Anything below that, it feels like, oh, I'm talking to something. And I don't know, you're too young for that, but there was a TV series, Knight Rider, in the past with a car you could
with
talk
the black
to.
car.
Exactly. Today it's maybe Iron Man and Jarvis, where the guy talks to his artificial intelligence that helps him. I think it's a fascinating vision if all the complicated stuff that surrounds us has an intelligence on board that you could interact with.
Yeah, and the thing is that you mentioned the Jarvis part, that, for example, ChatGPT and OpenAI just, I think it was a year ago, released the advanced voice mode, in which you can actually speak with it. But you still see that there's sometimes lags, and it's very expensive, even for them. OpenAI said, this is something, I just paid the Pro, that you in $200, and you say unlimited conversation with advanced mode, and then you realize that it's cost them a lot of money to do those conversations. So, and
if you look at the balance sheets of those companies, it's not working out yet. So I think we could do the math and say, well, it's still too cheap. If they really want to make a business out of that, it would be more expensive. And then it makes even more sense to think about, this should be on the edge device. I think a lot of stuff will be hybrid, where you have something on the edge, and then if you have a very, very indirect,
complex
question, you can refer to this. But a lot of stuff can be handled perfectly on the edge device, and there's no need to transfer massive data back and forth into a data center and inference there. Yeah,
and you can see that the majority of the models is now being much more powerful. Even 7B models, for example, are amazing, and you have like multimodalities that are a little bit, let's say 7 also, that you can still do a lot of things specific for your needs. And let's be honest, the majority of us have like this simple conversation and a simple task, nothing that too fancy.
For most of the stuff, it will
for the most of the stuff, you can do.
It's a little bit depressing if you say 7 billion parameters. Pretty much enough for you. But you're right.
I thought some article.
It's funny. We just demonstrated a 7 billion parameter model running on our chip locally on 10 watts of power consumption. And then you compare that, just one query you would put onto ChatGPT and compare that. Then you see already, wow, this is a huge difference. And if you want to have that intelligence in the device, it will not be on a device that consumes like 3-digit wattage.
It doesn't make sense. So can you please a little share what your clients, customers are building with your products? It will be fascinating.
Yeah. It's fun, I think. I give you something. I sometimes structure and say, I call it AI-defined products and AI-defined processes. What I mean with that is sometimes you put the intelligence into the product and the product does something, like the self-driving car. The AI-defined process is a little bit further away from everyday experience, but it's at least as revolutionary as the other side, which is, what if you if any process you run in a production plant, for example, you're producing something complicated. What if every process is handled as if a human expert would do like a craft specialist, task. Does it like with all the skill. Today, only luxury products are done like that, which means people doing this are super flexible. Like if you get a tailor-made suit, it fits perfectly because they do it just right.
For you.
It would be super hard to program a machine to do something like that. But a good tailor knows exactly how to do this so it's perfect. ML offers the possibility to get this into the process of production. And I give you one real example, which went public, and they published recently that they pick us now for every product they're doing. A company called Trumpf, so not like the American president, but Trumpf with an F in the end. And they are the gods of laser technology. They do like the most advanced laser technology. Every TSMC plant has their light source for doing the optics, the lithography for the chips. And they had this revolutionary idea. Laser welding is an old technology, but what if you do it on closed loop base? Basically, you're welding, and while you're welding, you see what you're doing and you assess what you're doing in real time. Because today, if you do a welding process, if you look at this, what they do is they do a weld, then they take a picture of the whole seam.
And then check it.
And then check, is it good? What you don't see is only the surface good? Maybe there are cavities under the surface you don't see. And you cannot change it anymore, right? If it's
Once
bad,
it's done, you need to destroy it.
So how does a human weld? Do you do some welding?
No.
So I do sometimes.
Okay.
What do? You light up the torch. You look through this window and you do closed loop. You're watching and you're doing this and correcting. And humans do everything in closed loop. Everything is checked and adapted. And what Trumpf had as a revolutionary idea was, what if we do the same thing? We weld, we watch, and we can correct in real time. In real time. So we can increase power, reduce power, whatever is needed. Focus up, down. The only problem they had was they couldn't make it run fast enough on a graphic card, on a GPU solution of famous big companies. So
you need a very high rate frame.
Exactly. Latency is everything. And you need to be very fast. So cloud was out of the game immediately. Exactly. Don't think about it. But even running this network on a GPU base was too slow. So the system was only half as fast as they needed it to be. And they heard about us.
Even the GPU was very slow.
Yes. Of course, you can say, okay, what if you put like 10 machines?
Yeah, but it doesn't make sense.
But basically, like what they wanted to have is one machine doing the job, of course.
Yeah. And if you want to do it on scale, it doesn't make sense to bring such...
And like think of a factory floor. You have dust in the air. You cannot have liquid cooling in a factory floor. And then
everyone will sweat.
Not good. So they wanted to have a solution that can operate that. And at that time, we had just beaten NVIDIA at the Machine Learning Olympics 3 times in a row, proven that we're much faster than them. And that caught their attention, that they contacted us and said, could you give it a try?
Do your magic.
Yeah, exactly. Show us. And we went in there and actually ended up 10 times faster than what they had before, way faster than they needed. They were completely excited. And now this is exactly what's happening. They're watching the welding while it's been done and can feed it back into the system. And there's tons of applications. If you go into any modern production site, there's so many processes that are still open loop, where the loop is closed in the end, that some quality folks takes a piece and checks it on once a shift, once a week, whatever. And if they find something bad, then they stop the whole line and say, okay, we
need to inspect everything.
We need to find that again or recheck the dial. And what you can do now is you can check every single part coming off that line as if you had the best foreman, the best expert checking every part, because you do it so fast. And if you see the part is still good, but it's going in the wrong direction, you could basically change the dials in the machine in real time and stabilize a product and always keep it good. So not only you have only good parts, you don't do bad parts anymore. And if you think about that, that's a revolution. Yeah,
you save tons of money in just QA and general stuff.
I believe this will be like one of those pivotal moments where companies that do it will dominate every other company that are not doing it, because you have this invaluable advantage. A lot of those companies are fighting over penny advantage in something. So if you do this is like a leapfrog moment in technology, in production technology. And we're just at the beginning of that. And that's just one example, which I think nobody would think of. If I tell you edge computing, edge AI.
This is the last one.
you wouldn't have come to this point, right?
Welding with laser now.
Exactly.
So.
Okay, but if you think about it, and then that like a world opens up of a lot of stuff that you can do in this direction.
But I have a question. Do they train their own models for that and then they put it on your hardware? So what was about that? So they train their model and then?
So in that case, they trained their own models. They had everything done, and they were happy with the inferencing result. The accuracy, everything was good. It was just too slow. So they got stuck at the point. They said, okay, we can run it, but it's not fast enough. So we're still not in line. It's going to be an offline, and then we wait for the result of that. We cannot correct in real time all that. And so the moment they were waiting for somebody can do it in real time and can tell you, and that's millisecond, not good. Re-weld that point now. That's a breakthrough moment.
So this is in manufacturing. You have also examples in automotive or raw or just other.
Yeah, I mean automotive. First of all, of course, everybody thinks of autonomous cars, robo-taxis, something like that. I believe we're going to see that, but the task is much harder than people thought, like 5 years ago. And if you listen to some companies, they're announcing every year, this year we're going to have it. And
next year we're going to.
Exactly.
Even here in Israel, we have companies like Mobileye said that in this year, Tel Aviv will be autonomous.
What I believe greatly underestimated the complexity of that job. But at the same time, every year about 1 million people die in car accidents. A million people. And if you look at those accidents, I would say 95% are stupid mistakes. People not paying attention, texting on their phone, whatever. And actually the number goes up, maybe because of smartphone usage. And I think the first real important task is put a guardian angel in every car that prevents you from going on the other lane or crashing into the tree. And that is a job that is doable with today's technology. What you need for that, however, is a different technology that's in most cars today. If you do adaptive cruise control, for example, a lot of times they just check the distance with a radar and they keep the distance, whatever. The modern technology we have in some cars out there is based on machine learning. Try to understand the situation, try to see the
depth,
path. Exactly, the depth, everything. The problem with that is it takes a lot of energy. And if you talk about electric cars, it's a big penalty. So I see as an immediate application for our technology exactly going into space. And we're talking to all of those folks about having a technology that, first of all, makes driving safer and prevents people from getting killed in car accidents.
And this is before the autonomous part.
And then you can add on. So there's a continuous path from, we call it level 2, level 2 plus, level 2 plus, 3 minus. So there's all kinds of innovative names on that. But I think what's important, you want to provide a technology that is a continuous path. You don't want to provide a technology where you say you can go to this point, and then you need to throw away everything and start again. And our idea is we want a technology that can be scaled to any level, to any complexity level, up to robo-taxis and fully autonomous cars.
So basically, car manufacturers can use your chips, and then they need to set some kind of algorithms, models, and then they can just put that in their production line, and then later on just actually use the sensor that you're developing in order to do some tasks?
Yes. So, I mean, you made the right points about the chip alone isn't the solution. So somebody needs to put in the algorithms, the full stack, how we call it. We're a small company. We cannot provide a full self-driving stack. What's interesting, if you had asked that question 6 years ago, there was a lot of chip companies out there claiming we can do everything. If you talk to their customers today, they would say no. There's not a single chip company today out there that makes their customers happy. Pretty much everybody is kind of disappointed because the promises were not kept. And I think no matter how big and powerful and successful those chip companies were, they greatly underestimated the job of self-driving. Because as a chip company, you think of, well, if my system has a blue screen of death once in a while, what matters? Don't care. Just restart. In a car, well, the blue screen of death is literally a blue screen of death, right? If the car stops controlling or something. So you need to reach a completely different level. And I think what they understood only over time now, how complex this world is. There were chip companies based in Silicon Valley, and maybe they thought we drive around the block in our nice little neighborhood 3 times. It works. We say, we done it.
Yeah.
And then you throw them in the middle of Tel Aviv and they say, oh my God, that kind of traffic? We never prepared for that. And then you throw them to Norway and France and England and left traffic and whatever. I think this complexity was greatly underestimated.
Yeah.
So this is right now, when you talk to car companies, you see this moment of, let's look at our strategy one more time. And that's an interesting moment for us. It's a perfect entry point for us. Because if those big companies would make everybody totally happy, what's our role then?
Yeah.
But we see it just the opposite. There's a great feeling of, the first shot wasn't the right shot. Let's
reevaluate.
Let's rethink what we could do. Yeah.
Yeah. So this is really fascinating because, as you mentioned, there's a lot of companies who said that the automotive will be, solve problem very, very soon. And then they figure out that, okay, this is much harder than we thought.
Yeah.
And part of it is, as you say, the hardware that can actually make this entire orchestration work. And I remember when I drove in self-driving cars, and you open the bagage, you see like a huge computer. Like I think I have photos of it, like a massive computer.
Yeah.
And so, okay, it doesn't make sense. It won't be. So it's okay for do the round the block, as you said, but it doesn't make any sense to do that in production for a lot of cars and make it energy consumption efficient.
Yes.
So this is something that I believe that if you will be able to improve what you can process, it will be much easier to solve the problem because there's a lot of sensors, a lot of data has been translated, and you need hardware that support that.
Yeah, and I believe it was the missing piece of the puzzle. And everybody understood the capabilities of machine learning. This is a new world compared to rule-based engineering where you try to program computer vision into, if you see this, do that. That gets you only that far. So machine learning opens the door. What they then realized is exactly what you experienced. It takes a huge machine in the back. The luggage space is gone. And you put like a lot of dollars into this car. Normal customers will not pay for that. So
no one can I want to put my actual luggage in that and not a computer.
You sit with your luggage on your lap when you don't need to steer anymore.
But you sit with the luggage.
You sit with your luggage. Then you can ask, what is the better driving, right? With the heavy luggage. No. So what was missing exactly this technology, and I think the problem came up because they take the same technology they use for data centers for cars.
Yeah.
And everybody learned this is not working.
It's
like you for that reason. In a data center, you have a huge air conditioning and you have unlimited power from some power plant close by. You talked about that.
Yeah.
But
you don't need to put your luggage on yourself.
Unless you have like a long wire that's connected to the car all the time. No, I think it does make sense. And I believe if you go to 30,000 foot and look down, technology has surpassed nature in a lot of ways. Like we can run faster than the fastest animal. We can fly faster than the fastest bird. We can dive deep as the deep sea, whatever. But if you think about inferencing or thinking, we're still right at the beginning. And what we're doing, like when you look at graphic cards consuming hundreds, if not thousands of watts.
Yeah, our brains.
And you do with 30 watts, you do like 10 times the performance. So I see there's so much space still to go into. And I think what we're doing is like the first step into this territory of you can do this so much more efficient. And it's not just the beauty part, like, okay, efficiency is nice. It's actually mandatory to be able to scale it into objects. You talked about robots, for example. Any robot needs to do this. I mean, they're not connected to anything. They run on a battery. Probably you want to save this battery for mechanics, driving motors. You don't want to use the battery for not bumping into things, right?
Yeah.
This portion of the job should be
Seamless,
reduced to the minimum
Yeah.
energy consumption. And this is why I think this technology is so exciting.
Yeah.
It opens the door for so many applications.
Yeah, so it's fascinating. You mentioned that before, that you have run some 7B LLMs models. Have you some examples of things that you have done in the Gen AI application?
Yeah.
Things that you build or your customers build?
So my vision is that any machine that today has an instruction manual will not have an instruction manual because you just talk to that machine. You tell the machine what you want, the machine understands you, maybe goes in a dialogue.
Yeah.
If you think about, you start with the complicated machines you have in production environment, where you need like 2 years of training to get anything done on that, because it has a million buttons until you know what to push. It takes forever. You could have a machine that you can talk to, that any operator say, hey, I want to build this, and then it asks you a couple of questions, you go back and forth, and that's it. You could think of a car where you sit in the car and you can ask the car any complicated question, it answers in real time. You could have the car, like think about you drive a sports car. The car could basically give you advice of how to drive better because it sees the camera, multimodal. You could give it even the voice of your favorite race driver. So you sit and he gives you advice and say, hey, that curve was really nice. So I think there's so many applications down to the level of kitchen appliances. Like think about your dishwasher. You get a new dishwasher, you actually have to open the instruction
there's a lot
manual
of
to see,
too much buttons.
This is the program. You
Yeah.
hit this button 3 times, and then they tell you, please connect it to the Wi-Fi. It never works because you have maybe 5. You have a new standard Wi-Fi 5 or 6, and it doesn't work. What if that machine is naturally smart?
Yeah.
If it just takes 10 watts of power.
But I want to double down on that
Yeah.
because we have seen many companies just make that promise that everyone
Yes.
will be smart, but eventually, for some reason, let's say whatever, it wasn't happening.
No.
And I want to double down because
Yes.
you are trying to, because maybe it doesn't make any sense to put a chip on dishwasher. It's too expensive. Or 2, maybe, it's latency. You said about a car and how you can teach the, but we saw a lot of promises for that stuff, but it never managed to
So I believe
become real.
I believe anybody coming out there and talking about smart thing this and smart thing that, what they really did is they programmed a couple of keywords. If you know them, you can operate this by voice. If you don't know them, sorry, don't know what you mean. What we're talking about, if we talk about Gen AI, you don't need to program anything.
Yeah.
So today, nobody has put that technology on a device yet. Why? Because there wasn't a technology. You don't put a graphic card with 300 watts of power consumption in that device, right?
It can warm up the dishes. So
You could use that as process heat, maybe. No, so again, I think the missing element is, can you put a brain in that is so power efficient that you actually can make it run in that thing?
Yeah.
So we believe the only reason why it wasn't done because the technology was missing. And there's a lot of guys, if you go to some conferences, they say, well, maybe by the end of the decade, we have technology that's ready. And sometimes I stand up and say, wrong, it's there already. We got it. So and then there's a lot of discussion going on. So I see a great interest from customers about that.
Yeah.
And I think it now sinking in that there is a breakthrough moment in technology, that there is technology that is capable to run this kind of complicated models. And what's fascinating to me, if you look at DeepSeek and stuff like that, the capabilities of those models and the requirement, that all goes in the right direction. So you get much more capabilities with much less requirements. So when you thought you need a massive compute to do anything reasonable, that needs to be in a data center. Now you find out, wow, you can do something really impressive just on an edge device. And just for fun, in our office, we invented a new game we sometimes play, like Friday with a beer, where we put our system up there and we ask the system, what situation do you see? So the task is one group writes down, make a position that the system thinks you're doing this or that.
Yeah.
It's
like a reverse jailbreak. You need to do something in order that the model to understand what
exactly.
Yeah.
So I think it opens up a whole new era of games you could play in terms of, but in the end,
but you're running like a model with camera that analyzes
everything on edge with 10 watts of power, just on the desk, sitting there with a camera. So it's there, the technology.
Yeah. So now, for the first time, you said that the technology is like the all-star line of it's power efficient, it doesn't cost too much, and actually can be used to run like a decent model that you will get something out of it.
Exactly. Yeah. And I think, if you look at DeepSeek and the latest papers, the fascinating part is that there's so much progress on quantization that people understand so much better that you don't need 32 bits floating point to do something reasonable. You could, again, argue, well, probably our brain doesn't have FP32 as a data format either. It's going to be different, maybe in 2, in 4, something like that. Yeah. But it's fascinating. For us, it's great news because our technology is geared toward that. How do you have a lot of tiles that work simultaneously in a very efficient data format? Mm-hmm. That's the secret of our power efficiency. And I think we're without knowing, we're mimicking nature, which works in this way. And I see all of research going in this direction. So for us, it's a great time. Our product is just there, and research pointing exactly in that direction. It's all going to be edge.
Yeah.
It's all going to be lower accuracy on data formats. Nobody needs FP32. That's over. So that is a great push for us, and we are super excited being part of that.
Yeah, I see this is something, even in the inference world, you see now companies like Mr. or even Perplexity are using Cerberus as an inference. Yeah. So that you see that there are companies that are more open-minded to think about all the paradigms that they've already had about, okay, we want to run we train the models, okay, nice. But now we want to understand what we can do that.
Yes.
If it could be like in even scale or maybe in the edge. And now, this is also what I see, that it's become suitable in order to do something that is not the obvious. And now you can say, maybe, it's actually makes sense to put like a very small device, a chip on a very small device and see what happened. Yeah.
Exactly. And I really believe, of course, development doesn't stop here. So we see the next generation and the next generation. If you put all this together, I think this is the beginning of something. This is not the end point, but this is the beginning of something.
Yeah. I think there are a lot of things to come because, as you said, if we don't have the problem of latency, privacy, and the cost, we now enter in the area of true personalization. Because now on my phone, it's okay for my phone to listen, to watch, to do whatever, or even for my computer to see what I'm working in the background, because I don't care. It's all in the device. Yes. And now, for the first time, we'll be able to do actual personalization because the model can really learn with the data that I'm happily going to share with.
Yes, exactly. And it learns with you. I sometimes make the example, I have a favorite soccer team at home that I'm sharing. It's not an important soccer team. Yeah. So maybe the first time I ask my device, how is my team? It's Preußen Münster. It's a little northern town in Germany. How is that playing?
Yeah.
Next time, I'm just going to say, how's my team playing?
Yep.
And this is why I think it's so exciting. This will be a new level of interaction with this. And as you said, you don't want to have that with the data giants that they send me advertisement for my club. I say, no. I guess like me, most people click, no, I don't want to share data. No, I don't want to make you smarter. No, I don't want to have personalized ads from you. And they ask you every time. It's good that they need to ask. But one thing is clear. If we get into this AI assistant something, they won't not put a choice to you. They say, if you want it, we get everything. That's the deal.
Yep.
Right? And then it's a different story. And I wonder, I probably don't want that this machine somewhere knows everything about me. You know?
Yeah.
Well,
And the thing is that in order to create a really personalized, you need something that's much more than just text.
Yeah.
And this is people, they don't realize, this is why I'm so excited about multimodality, because for the first time you can actually have the same sense as humans have.
Yes.
And for the first time you can actually grasp the entire, let's say, real life or interaction that human has. Because if you only, even with all the data that Google, Meta, whatever have, this is only the text or maybe the voice. But think about the model that can actually understand the entire, let's say, context of your life. This is so powerful. And you need to be private, as you said, but also you need the hardware to support that. Because nowadays, even if you would like to share everything with Google or whatever of the world, it doesn't make sense economic-wise, hardware-wise, whatever-wise. Yeah. And this is why I'm so excited about this technology, because for the first time, a new technologies that maybe they are let's say already developed or already, but they are not suitable for actual usages. You understand my point?
Perfectly. Perfect. I think always just think about how people interact with each other.
Yeah.
Just imagine how much is missing if I don't see your gestures. If I just, this is
the hear my voice. Yeah.
That's the difference between a phone call, or even worse, you send me an email. Think about all the miscommunications we have as people by writing stuff.
Even with
other.
Podcasts, when we are sitting in the same room, it's a totally different if we are doing like in a video conference.
Okay.
And this is the same media, so I can see you, but there's a lot of other active things.
I mean, we all learned during the pandemic.
Yeah.
If it's not a one-on-one on Zoom or Teams, if there's like 10 people, you just see the little faces. You don't see any. And I think what we now learned, how much is dependent on reading emotions, like irritation, a question mark, like a sign of I agree or something like that. And if you think about an artificial intelligence that can pick up those signs.
Yeah.
So you don't always have to say something, but sometimes you just can you pick this up?
Yep.
Not, could you please pick up the box that sits at the table in this box there? No. I think really all we need to do to make it really good is mimic what we're interacting as human people. Yeah. When my wife tells me, hey, Harry, could you pick this up?
You understand.
I don't say, please give me the coordinates of the object and tell me exactly how heavy and this and that, and then program the path towards something. No, it's the interaction we have as humans. That should be always the final frontier to get there.
Yeah, I really agree. And I want to ask, just for conclude, we spoke a little bit about what do you think will be the vision of this entire industry, but also for SiMa, and how you see the applications are now being integrated to what you're building and how this coexists. So I'll be happy to hear your thoughts about what you are planning and what you see the market is going to, and see how it's, collaborate together.
I think it's the most exciting times we could imagine, because we're at this brink of a breakthrough. We see, just you and me have put so many ideas on the table where we think, well, this would be really cool if we had that, if we had that. And I think,
and the laser whelming.
And the laser one. I don't know if you need that at home, though.
It will be funny. Why not?
Maybe, yeah. So let's think about that. But I think it's a great point in time to be part of that. Of course, SiMa is excited being part of that. We think we have a crucial piece of the puzzle to fulfill this dream. We're working with a lot of partners together, but for me, it's like a feeling I can't wait for the future. And it's like this excitement of, wow, every day something happens. And when DeepSeek broke out, and said, wow, this is a big moment. They call it the Sputnik moment, where we saw like, oh my God, this is a different path we didn't look at carefully enough. And it's a great news for human mankind, I think. And I'm a hopeless optimist, but I'm not pessimistic in terms of what does that mean for human mankind. I think it will make our life better. I think we'll get free of a lot of tasks that are boring anyway, and let's see what we use that time for. Maybe we use that time in the good way and do something which we couldn't do before because we were so tied up with tasks that nobody cared about that need to be done. So I think if you look at the whole picture, that's super exciting being part of that, and we can't wait for it.
Yeah, I totally agree. And in the phase of things that are just changing, evolving, sometimes on daily basis, it's really amazing. I think the fact that you are building the platforms that allow all this to happen, and you're very interesting part because all this new and cool application can come to you, and you'll be able to just play with that and assess and see how it's actually happening. So thank you all for your time. It was fascinating. It was so much fun to learn about what you're doing and think together about all those cool use cases of just how...
You'll never forget the laser.
Yeah, the laser. Yeah. This is a good one. No, actually, this is something you will never come up, as you said.
Yeah.
So thank you very much.
Thanks for inviting me. It was a pleasure.
Same
really
here.
Fun.
Thanks.
Thanks.